Okay, so for this part of our notes, we're going to go ahead and okay, let me start over. This part of our notes is located right after the light calculations. Okay, so yesterday in class, we introduced electron configuration using our boarding house analogy. And today we are just picking up in our notes where the light part ended, and now we're starting electron configuration. So it says, basically, we're going to start talking about like what is the principal energy level? What does that mean? And then we're going to talk about levels, sublevels, and orbitals. All right. And so we're going to learn a little bit about how we come up with those numbers 2, 8, 18, and 32 when we're talking about how many electrons we can fit in those rings of our Bohr models. So you remember we were talking about our Bohr models and how many we put in each one. And now you're going to kind of get to see how all of that comes together. Okay, so it says electrons can be found in specific energy levels around the nucleus. Energy levels around the nucleus. The term principal energy level, symbolized by an N, refers to the lowest energy level occupied by an electron. So, principal energy level. You guys have seen me write the n, like n equals 1 and n equals 2 when I'm referring to different rings around those Bohr models. I'm talking about these energy levels, okay? So the principal energy level is that lower energy level occupied by an electron. So as our n increases, all right, so as the energy level, the principal energy level increases, the orbital becomes larger. The electron spends more time away from the nucleus, and the atom's energy increases. This makes sense. We've been talking about this, right? So, I'm just going to like draw a little Bohr model. So, as we have our Bohr model, we know that the electrons that live close to the nucleus have the lowest energy. And then we also know that if we add energy and these jump up into a higher energy state, because they're absorbing energy, like energy's coming from somewhere. Okay, they have to have more energy to be in those higher energy levels. And of course, eventually they will fall back down, and that energy is emitted. Okay, so just a little tie in to what we were learning before. Um, we'll say it's light. Yes. Okay. So when we're drawing these Bohr models, we've talked about this a lot. We can only fit two electrons in that first ring, okay, that first energy level. And the second energy level, we can only fit eight. In the third, 18, and then finally 32. So that should sound familiar to you. We know that the locations of electrons aren't exact, but we can predict where they may be based on energy. So we're going to predict. There are four possible sublevels that can exist with different principal energy levels. So here we have our S and P and D and F. And if you were following along um, with the boarding house analogy in the previous video, then the S and the P are kind of like our sunny rooms and our pink rooms. Okay. So each sublevel is used to describe different orbital shapes. Orbital shapes. Each sublevel is made up of different amounts of orbitals that can each hold a maximum of two electrons. Okay. All right. Our sublevel S. The shape of a sublevel S is pretty spherical. Spherical. There we go. And then P, D, and F. For now, let's just think of them as having various shapes. Okay. It's important to know the number of orbitals that we can have in each sublevel. So, in our boarding house activity, it's kind of like we could only have two boarders in a bunk bed. The orbitals are kind of like the bunk beds, and so in that S sublevel, we only have one orbital, and it can hold two electrons. In P, we have three orbitals that hold six electrons. In D, we have 5. So this is new. We haven't talked about D and F up to this point. So D has 5, and that means 10 electrons because you can hold 2 per orbital. And then 7 orbitals is 14 electrons. All right, so this is kind of how many orbitals we have in a sublevel and how many electrons they can hold. All right, so now we're going to see um, which sublevels exist in each energy level. So we know in principal energy level 1, we just have the S. We know that we have one orbital and it's going to have two electrons. And so the total number of electrons in that energy level is just two. All right, now we're in our next principal energy level 2. All right, so we're going to have sublevel S and P. We already said that P has one orbital that can hold two electrons, and we know that P has three that hold six electrons. And so in that second energy level, we have a total of four orbitals that can hold eight electrons. Is this starting to look familiar to you? Okay, first level two, second level eight. Now we're moving into that third level. We can have an S, P, and D sublevel. And if this is the case, we already know we're going to have one orbital in S, three orbitals in P, and that means we can hold two electrons in S, six in P, and then with D, we said five orbitals for 10 electrons. Okay, and so that is nine orbitals resulting in 18 electrons. The last one we're going to talk about, S, P, D, and F. In this fourth energy level, we start to be able to hold all of the sublevels that we're going to talk about. So 1, 3, 5, 7 now, which would result in 2, 6, 10, and 14 electrons. We have a total of 16 sublevels, allowing for 32 electrons. Okay. So now it's asking us, circle the orbitals that do not exist. Okay, so in that first energy level, we could have a 1s, totally fine. Could we have a 1p though? Well, no, p does not exist in that first energy level, nor does d, nor does f. But as we move to the second, we can in fact have the 2s sublevel and 2p. Okay, but we do not get to have a D sublevel until we're in the third energy level. So we can't have a D or F in that second energy level. Now moving on to the third, we can have an S, a P, and a D, but we cannot have an F. And then as we move to the fourth and so on, then we start to be able to accommodate all of those sublevels and their orbitals. Okay, so I think I am going to stop right there and make another video about the rules for filling up the electrons and atoms, and then I'm going to tie the practice into it. So I'm going to kind of do the notes and practice packet for the rest of these videos, going through the notes because the way that we're going to assess your knowledge is a lot to do with practice. So, all right, thanks so much.